In this lesson, we will learn about Azure data centers. First, we will learn about Azure data centers, then for domains, update domains. After that, we will learn about availability set and proximity placements group. Finally, we will conclude our lesson with the review questions. As you may know, an Azure data center is a unique physical building that contains thousands of physical servers, usually installed in server racks. Each Azure data center has its own power, cooling, and networking infrastructure. So what is a fault domain in Azure? A fault domain defines a group of virtual machines that share a common power source and network switches. As you can see, each server rack has its own power source and network switches for its physical server hosting the virtual machines. If the power source or network switches are down for any reasons, then all the VMs in the server rack will be down or become isolated. Therefore, each server rack is a fault domain, and in this diagram, we have 5 server racks, so we have 5 fault domains. Let's now learn about Azure update domains. An Azure update domain contains a group of physical servers spreading across many server racks that can be updated, restarted at the same time. This allows Microsoft to perform patching and software update to all the physical servers in the same update domain without impacting its services. For example, in this diagram, Microsoft can segment the server racks into 4 update domains like this. Now, to perform patching for all physical servers in update domain 1, Microsoft first migrates all the VMs in the update domain 1 to other update domains, then perform the patching. During the patching, the physical servers in the update domain 1 can be shut down or restarted at any time without impacting any virtual machines. After the patching is completed, Microsoft will repeat the same steps to patch all the physical servers in other update domains. So what is an Azure availability set? An Azure availability set contains virtual machines with the same functionalities. Azure makes sure that the VMs in an availability set are placed in different fault domains and update domains. For example, if we deployed an availability set which includes 5 VMs in this diagram, here is a possible deployment. With this deployment, if one rack is down, we lose one VM, and if 2 racks are down at the same time, we lose 2 VMs. Also, when Microsoft performs an unexpected update in the update domain 1, and the VMs in the update domain 1 cannot be migrated before the update, so we lose 2 VMs. However, in these cases, other VMs are still up and running as normal, which means the application is still functioning and serving the end users as normal. As you can see, the availability set allows us to get the highest availability for our VMs, which in turn gives us the highest availability for our applications. As you may know, if a zonal resource is not configured to deploy to a specific zone, it will be placed in any zone in the region. For example, we have a 3-tier application which requires low latency between VMs in each tier. Now, when we deploy the first VM in our application, it may be placed in zone 1 like this, and the second VM is placed in zone 2, and the third VM is placed in zone 3. This becomes an issue because our application requires low latency between our VMs. To solve the problem, we need to create proximity placement group. A proximity placement group is a logical grouping used to make sure that Azure compute resources are physically located close to each other. Proximity placement groups are useful for workloads where low latency is a requirement. A proximity placement group is a resource in Azure. You need to create one before using it with other resources. Once created, it could be used with virtual machines availability sets or virtual machine scale sets. So in our example, we first need to create a proximity placement group and put it in zone 3, for example. Then we create the first VM and associate it with the placement group, and the VM will stay in zone 3. Now we create the second VM and associate it with the same placement group. Then the VM will stay in zone 3 and very close to the first VM. Finally, we create the third VM and associate with the same placement group, and the VM will stay in zone 3 and close to the other two VMs. Now let's conclude our lessons with the review questions.